Today our guest is Michael Flach. Just some organizational points of view. Don't forget to upload your tasks on your participant folder, not later than the 11th of July. So the task description you'll find on OLAT, so feel free to upload your task. And today Michael Flach will talk about a special topic related to refurbishing. Michael Flach, along with wood pioneer Julius Natterer, has received awards for countless timber construction projects in France. And in 2002, we know each other since more than 10 years now, I think, he was appointed to the University of Innsbruck to establish a chair for timber construction, which has gained international recognition through its practical research and development. He purchased a 500-year-old farmhouse in Schnitz Valley and renovated it into a passive house. His focus is on resource efficiency, sustainable construction and renovation, for which wood is the ideal building material. So we are looking forward to his presentation today, which is about transformation and refurbishing of an old farmhouse in a multi-generation house with high energy efficiency. Welcome, Michael Flach.
Thank you. Thank you, Rainer. You switch on, I just go ahead. Yeah, it's the first time in this nice room here. It's huge. Not many people, but I guess all the people are outside, watching from outside. And yeah, I'm retired now since 5 years. But as you can see, I'm still teaching. I'm looking for nice places to teach. So I'm teaching every year in Corsica because I speak fluently French. And I'm teaching also in Italy, in Rome every year. And I'm teaching, since last year, I'm quite often in Bhutan. You know, Bhutan, the Kingdom of Bhutan. It's a Himalaya state. And I just came back after 4 months of English teaching. So my English might be a little bit Bhutanese, but it has improved because I don't speak English very much. Yeah, Rainer told us it's about refurbishment, but it's about climate protection. We know the last numbers of heating warming up. We have now here about more than 3 degrees of warming up, so we really can feel it. We can feel the consequence, especially here in the Alps. We have seen in Switzerland what happens when the mountains defrost and rocks are coming down. So I just give a summary first. So you have everything in German, in black, and in English in green, except it's the last part, it's only in English. I speak a little bit about my background. It's a little bit philosophical. I have a special approach about engineering. I'm speaking about, it was a doctor thesis about ecological timber facade, which was quite new because most of the facades are made with artificial materials. And here we had a system which is prefabricated with ecological insulation material. And then I speak about my farmhouse. My farmhouse is only 25 kilometers from here, 1.5 hour bike ride. In the valley, it's a little bit cooler there. We have in the night never more than 18 degrees, so it's nice to sleep there. And I will speak about how we transformed this house. Transformation or refurbishment is coming more and more, and we put more and more. We have to ask before refurbishing if we break down a house, if we build a new house, or if we refurbish it as it was before. My solution was a little bit in between. So I mixed up new and old, and you will see it's quite exciting to mix up the different living cultures. And then I will speak a little bit about a smart timber grid. My very last structure, it's a redundant system. I give you some ideas about redundancy, which is a quite clever natural principle. So here a look back to my first office. So I studied in Munich. So I'm a civil engineer. Then I went to Paris, and I I specialized concrete structures, and then I went to the biggest concrete company of the world, for 5 years to see how concrete is going. And then I was born after 5 years and switched over to timber. Timber was always my passion. And I see most of you are young. If you want to be a good scientist or engineer or whatever, just choose a spiritual father for you. So I was looking for the best timber guy I could find. It was Julius Natterer. He was a timber pope at the time. He was teaching in Lausanne. So I asked him to work together, and after some years we worked together, and we created an office here in the mountains. These are nice mountains in Savoie in France. We were surrounded by mountains between 3,200 and 3,900 meters. So we had a lot of hanging glaciers. I'm not going back anymore in the summer because it's so frustrating to see all the glaciers and the snow gone. Now we have a black rock facade all around, but it was really a spectacular ice curtain we had, and now we have also big hang sliding and avalanches there. And this was my house. The specialty was in winter we could not go by car there, though all my co-workers had to be a good skier. And if you look at the nations, we had good skiers from France, from Switzerland, from Canada, also from Austria. And most of my co-workers, they opened later, they learned with me, and they opened later specialized offices for timber engineering in Canada. So he just came over. David Moses in Toronto, he was last week here. And same thing in France and in Switzerland. We have now a nice network of good people. We were just starting up. So just some principles I learned from Julius, but I learned especially from nature. I think it's for everybody interesting how we can approach problems as scientists. I learned during my studies, I learned to handle with codes, with formulas, calculating, doing design, but I didn't learn how to design a structure. To calculate something, you need first a structure. You have to design something, and you don't have to calculate from the very beginning. The best thing is you have a good intuition, but you have a method to design. And I was teaching here in Innsbruck for 20 years how to design structures, also how to calculate them. But this is a final issue. You first need a good concept, and it's like a check game. You have parameters. They're always different. Every game is different. And you have to find the best solution to your problem. So this is a quite sporty and exciting task. And so you first have to design. And then you have here some parallels. You know that the function is giving the form. We have some basic rules we know from engineering. But I was also teaching to architects to make them discover the secrets of how forces are traveling in a structure and how we can design nice structures. And then there was another thing I have come basic for my work. It's a tree is a good example. A tree is growing always with the principle of economy of resources. A tree just grows with the material he needs to stand up. You can measure, you see here some graphics here, you can see here on the branching here that the tensions, you have the yellow color, they are constant on the outside, and a tree when he's growing, he is always measuring the inner tensions or stresses, and then he add material to make them equal. So you don't have weak points or strong points, he add just the material where it's needed. So he's quite clever, quite smart to adapt a structure during his life. When we are designing structures, we can at least try to find the best form to reduce the quantity of material we need. And today we have to be economic with timber. We have a lot of forests, but the forests are suffering from climate change. We have a lot of damages in our forests now. We have about 30% of damaged harvesting, damaged by wind, by dryness, by bugs, by hang gliding and rising temperature, because trees, they are sensible on temperatures. So they have to travel upwards. If it's warming up, the trees, some species have to go up to keep the same temperatures for their best life conditions. So in Germany, we say, or I say, wer verschwendet, der verschwindet. So it's a natural principle. Nature never is spoiling material. And if it's something too clumsy, too big, it will just disappear by a natural process. And we should take care of this process, because we're doing a lot of very heavy, clumsy buildings today, because for engineering, it's easier to have a heavy, simple structure. You get more honoraries for it than to try to reduce material and to get less honoraries, because you're paid proportional to the quantity you are calculating. So the system is not very encouraging to reduce your resources. And this is my kind of structures. They look complicated, but you see there's a kind of passion and there's a kind of approach seen from the nature. And the nature never have simple linear beams as we see it in 90%. You just look here upwards, you have always linear beams, very easy to calculate, very poor design work. But in the nature, if you see the branching, they are always spatial structures, they are interconnected, they are redundant, and they are much more effective than the simple structure here. I will come back to it in the last part to explain you. When I applied for Innsbruck, we were 20 candidates. I was coming as an outsider from France. Nobody knew me here. And I was the only one who had no doctor thesis. So at the end, I was chosen in front of the 19 doctor theses because I had practical experience. And because I announced when I'm teaching, I teach how to design and not only to make formulas or mathematics and no construction design, as I suffered when I studied. I suffered from the poorness of design, of the principle of design. And if you want to design, you have also to work, you have to apply. I have been one of the, I lived in a period, we were pioneers with digital technology in designing. So I had the very first CAD license in France with CAD work. So I had you have seen the office was very small. I don't have a place to have a design table. So we decided to do everything on CAD, on computer, to save place. And so we get pioneers of digital designing. And then after designing came the fabrication. You have the CNC machine who gets the information from your CAD plans directly without paper. And then you have a very precise full production. And modern timber structure has made a big step. We call it Quantensprung, a big step because of digital technology. Because in wood you are working very preciseful. Everything is calculated in parts of millimeters. Everything is very proper, very just. And with digital techniques, we can do a proper and high quality work, and especially we can work on complicated, complex structures with spatial geometries. So this is thanks to the digital technique. So the first thing I built up here in Innsbruck was a workshop for modeling. So students had to build first before calculating, before learning anything about wood or materials. They had to build a model, and then we were testing. And then they saw on the result of when we raised the load, the ultimate load, they could see why it's breaking, and they learn more about seeing their own work to know how structures are working. So the model laboratory was the first thing, and the second was I ordered a CNC machine, a Hundeke CNC machine, a big machine. It took 3 years to get a place because the colleagues don't left place to install the machine in Innsbruck. So we pulled up a cooperation with Upsum. There's a timber college, and they built the building, and I brought the machine, and we have a kind of cooperation. And then students had to learn how to handle the CAD drawing, and then we built some, you see, some amazing structures. This is a parametric design. We built this shell within 4 weeks. They had to cut it, to design it, to cut it, and then they had to bring it in form. You see here these belts here to curve it, to smooth it, to make in cuts. So they had a really strong experience. And a good souvenir about the structure, it was, you remember, it was for 2 months, 3 months. It's the entry of our building. It's made of 42 elements, which are all different. And everything is so precise. You stick them together and you make amazing thing. This is just a pedagogical experience, but they learned. And then we built other buildings here also with CAD. We collected pieces from Tyrol, and then I loaded a big truck to bring it to southern France, and in 1 week we built a passive house barrel, which is a tiny house for students. So I came 2002, so it's 20 some years ago. I always live in periods with 23 years. I came with 23 years to France, and at 46 I came to Austria. And after 23 years now, I'm going to Bhutan, and we will see if I have still 23 years left for Bhutan. We will see that. And so I was a new generation of professors. So timber was a new material. So I raised up a timber chair at University of Frick, which is astonishing because Innsbruck is a kind of capital of the European wood industry. You have here, inside a circle of 200 kilometers, you have all the big players of the timber industry, especially the glulam industry. You have Binder, you have Pfeiffer, you have Egger, you have Rubner, and some others which produce more than a half of the production in Europe here around with the wood we get from here. But they had no design training and no timber engineering, so it was time to build it up. And then I felt that timber alone is not enough, and I was happy when Wolfgang Feist came. And I asked him, I phoned him to Darmstadt, if he preferred to live here in the nice mountains than in the cloudy Darmstadt area. And he fortunately, he accepted. So we shared, I guess, 15 years together, and we worked on projects together. And then there was Wolfgang Streicher. I don't know if you know him. He's more in the energy field, but he was a very good complement for our research work. So one of our projects was a smart city project. You worked on it too, I guess. Everybody worked on it. It was, I don't remember the date, it was 2012 or 13. It lasts 7 years. The idea was to make a demonstration project, how to reduce the energy consumption for heating in cities or in districts, to reduce them by 50% about. So by refurbishing, by renovation. So we are now in the topic, and then there were measurements. So we worked on it, and it was finished with monitoring. So everything went well, but I was not very happy because I was hoping that there would be some work for timber engineering or timber refurbishing. Everything was done as business as usual. That means 99% of our external insulation is polystyrol, artificial insulation materials. And the first things we did a life cycle analysis between artificial classical insulation complex and ecological, made of natural fibers, of wood fibers, of hay, of cellulose. And then the reason to do that is I completely agree that passive house is the best practice, the best solution we have today, and I agree with everything of the concept of Wolfgang Feist. But you see, when we have a bad insulated house, we have the gray column, which is a heating energy, which is huge comparatively to the energy you have to invest in a building. But if you improve the efficiency in a passive house, we are reducing by 90% maybe, or by a factor of 10, the energy consumptions during the lifetime of the house. But the amount of the energy you put to build the house will be at the end bigger than the energy you need for heating. Not because we need so much energy to build a house, because we reduced so much the energy amount for heating that we can now check if we want to reduce more our gray energy, how can we proceed? And you have here, this is an old statistic or study from Julius Natterer. He was comparing here 4 beams, same span, same load, and then we calculated the amount of released CO2 for every beam just for the fabrication. And you see, if you have aluminium one, you have emission of 327. It's going down to 76 if you're going to steel. And you see the wood column is here, the amount is here in green, it's minus, which is mean the wood timber will store CO2. The time, if you take a timber out of the forest and you plant a tree, if we have durable, sustainable forest management, we don't have losses on the spring. Everything we save and we store it, the mass will be stored CO2. So we have a negative balance, and it needs some years to convince the customers. But today it's clear that if we substitute concrete by timber, we save per cubic meter, we save 2 tons of CO2 approximately. So in our balance, if you see today's the climate change, we have to care about everything which can reduce the climate change. So the same thing is for the insulation materials. So I started a doctor thesis with Clemens Lelevé. He did his work on a topic which is called the ecological timber facade. So we had some basics, some principles for his work. So we wanted to have standardized elements, timber frame, which is the cheapest mode of timber construction. We only use ecological insulation materials. We didn't have ventilation because it's a cost question. And then we need a system to hook it, to fix it on the facade. So this was one part of his work. We call it a system connector to make it easy. And it must be conform to the passive house standard, open vapor diffusion. These are some physical basics we respected. And then here we did this LCA analyze. You see, for the fabrications, the difference is not very big, but if you take account of the recycling and some of this material were quite toxic, and recycling was quite expensive, and even with the energy balance, we had a difference of 40%. So insulation is maybe only a small part of the building, but it's a part of it, and if we can reduce it, it's normal to substitute. And then we have the proceeding, the process how to use this panel. So the first thing is we in timber construction, we were used to digital techniques. So we made the inventory of the building with, what's the name? The name is a tachymeter. Tachymeter is a kind of laser machine. He sends you a cloud of points on your subject, and then he gives a digital print of your facades. You can have very complicated historical facades. It gives you really like a plaster, a digital print of it. And then the next step is to bring it to your CAD system. We were used to it to work on CAD. As a cloud of geometrical data went into a CAD program, and then you can build in a factory by prefabrication in a workshop. You build an element which is fitting to your digital imprint you made of the facades. So you have the counterpart, and then you give it, after CAD, you bring it to a CNC machine, and everything is very precise. You don't lose data, you don't lose precision, and everything is going very fast. And then you have computer-assisted cutting design. Here you see these are easy elements. In America, all the buildings, the 2x4 frameworks are doing this way. And then we had the transport and montage of it, but we needed also a connector. So I show you the work we did on a connector. The connector is made of two parts. There's one steel part is fixed on your wall. Now you can have different types of wall, different qualities with two bolts, or I will show you later. And then you have another part is fixed on the prefabricated element. And then you connect them together, and then you have a kind of millimeter regulation to put your prefabricated element in vertical or horizontal equilibrium to make it fitting very preciseful. So we developed a steel connector. We tested it for all the loadings, and so this is a systematic concept to avoid complicated design and to make it ready for a market to produce it in a big number. And then if you produce this kind of element, prefabrication element, you face all the fire test you need to have a certificated element. You cannot just build as you want. You have to prove it, and you have to do more than calculation. You have to make some fire tests. So with the company Neue Heimat, you know them here, they invested, they give some money to do the fire test, and now we have the certificate to use this prefabricated elements for at least or maximum 4-story buildings. If you go in higher altitude, it's more severe, so we just go step by step. Yeah, and then you need somebody to test it. So I was the one who tested it. I bought a farmhouse, not only for the test, but I was always dreaming as young engineer to. My first business concept was to buy an old farmhouse, to refurbish it, and then to sell it for a good price, and buy 2 other farmhouses, and to have a kind of snowball system to get a rich man. But things happened differently. But coming to the retirement, my dream was still open, and I had the time to look for an old farmhouse, which is not very easy here in Tyrol because everything is expensive. So I was traveling 2 years with my bicycle in every valley to look for farmhouses. You cannot easily buy a farmhouse if you're not a farmer. It's reserved to farmers. So I had to buy a farmhouse where the former farmer built a new one and takes the right of use in this new farmhouse. So I found one here, really by chance, which is affordable. It was not so expensive, and I liked it because he has a nice south facade with the bracing system. You see it, but it was a huge building, about 600 square meters. This building has already a history. It was, I told you, it's about, it's precisely 400 years old. So many of the old farmhouses have this age. And then it had been transformed with the history of the building. So it was first a 2-story building, now it's a 4-story building. But this farmhouse has a history, and for me it's important to respect the history of this building, not just to cut it down. The idea was not to cut it down. It could be less expensive to break everything down, but the energy balance is very bad, and this is cultural heritage, and this is kind of our culture, and so I absolutely want to preserve it. So I started in 2015, and I worked 8 years. You will understand on the pictures why it took 8 years to renovate a farmhouse, because you have many good and bad surprises when you are starting a work. So I was quite old, but I want to respond to this challenge, and now I'm happy to do it, because with the time we have, the alias with energy prices, and I'm sleeping very well because I'm conscious that I contribute to climate protections with a nice farmhouse. Especially all my 3 children, they joined me in this project. I proposed them to help them financially in my means, but everybody has to take a credit, everybody has to finish up the house himself, because buildings are expensive today. If you want to buy an apartment, you are very quickly close to €1 million for a small surface, and nobody has it. And so we decided to do it together, and children invested, and I helped them. So this was the first step, that Taki made an inventory. It's Michael Wurman, he's taking the picture of the facades. Then you have Robert, he put it into the CAD program, and here you have all the cuts of the structure. And you see the wall is not straight, it's curved. And even in the different heights, you have different thicknesses. So the things are not very easy, and you have to know it. You must do this inventory to prefabricate something who is fitting with a precision of 1 millimeter or 2 millimeters. If not, you have no airtightness, you have empty spaces, etc., and a lot of work. But if a machine is doing it, everything is prefabricated, and things are going very easily and very fast. So we started prefabrication. It was about 10 kilometers from the Knitztal in a carpentry. So we had the structure. We put also the window. We had to change the windows because the windows were old with simple glass, so we had triple glass windows. And even the opening around the windows, we had a special geometry, and you can already see here the different metal system connectors, but you see also the different pieces of wood with different thicknesses, so adapted to the geometry of the wall. So there was nothing constant, nothing similar. But if you do it with a digital tool, it's easy to do. You just follow the different steps, and then you have a well-fitting prefabricated element. So first the wall looked quite easy. It looks straight and everything. I want to keep the same opening of the windows, because it should have the same exterior after. I don't want to make a modern architecture house. I respected the pattern of the windows. And then looking a little bit more preciseful, you see all the damage in this wall. It was a cheap wall after he has crossed different world wars and poor living conditions, and there was moisture everywhere. They had no water management. They were so. And then you see on the top here on the right, you see a big diamond saw. We had a part, he was outstanding of the wall, and we could not. We were so close to the border, to the neighbor. we couldn't even not insulate if we don't cut a part of the wall. So we have to cut it. You see the saw here. But with modern tools, you can do everything. There's always a solution. So we cut the wall, and then we did some opening. 2 or 3 windows, we make them bigger, and we had to go inside the building too with a big bagger to dig inside the house. So we had really a dirty work first to do to renovate, and this was the condition of the facade after refurbishing to repairing it. We have a socle, the basic area. We had a sealer. We had some additional insulation, which is waterproof. And you see here the connectors. The connectors, we did some testing, and we found out that the wall was in so bad conditions. We needed steel shrouds going through the wall and to be anchored on the backside. On the backside, on the level of our floors, we put out all the floors, and we kept the floor on the inside in balance with the prefabricated element. But then you have to drill in a big wall, and if you try to drill straight a hole and you have a stone, your driller is going 2-3 centimeters elsewhere. So we drilled very precisely from the inside, and from the outside we just let it as it was, and we did our tachymeter inventory, would take account of the real position. So we don't have problems with drilling not straight. So by this digital imprint, we can take account of it. So it was not difficult to do that. And then the elements were coming. So first, you have 3-4 months, nothing happens. You are just digging in your house, putting all the gravel out, and then the elements are coming on trucks, and then a machine took every element, and this is the first day of montage. We started in the ground floor, so we had elements of about 3 meters high. It was the height of our floor, of each floor. We have determined the height of the different floors. We made them equally with new levels, and the length was about 6 meters for transportation. And then you have a prefabricated element, and every element you put it in half an hour, 1 hour. And there are just 2 people to handle it. This is a nice building phase in timber engineering or in timber construction. You have engines, you have 2 or 3 people, qualified people who know how to handle it, and then it goes very properly, very quickly. And in 2 days, this was the second day, our house was insulated. It was not finished insulated because we have the interspace. We have an interspace of 10 to maybe 20 centimeters. Was not constant. Element was constant. It had constant thickness, but the interspace was compensating the geometry of our wall. And then we have to blow from every window. We have to blow in insulation from every window. You see it here. We blow in here the cellulose insulation from inside to fill out the empty space between the prefabricated element and the wall. So everything is filled out, and then we have a good homogeneous insulation. And this was just before, in June, and 1 month later, the winter was coming. I was living in the house some weeks later, so we had to work on the inside now. It was not so cold anymore. And I told you the floors was in very bad condition. It was timber floor. The house was not inhabited for 10 years. It was not heated, and so you imagine the moisture conditions in the house. So everything was so uncertain and even dangerous. So we broke out all the old beams. So sometimes we had 3 stories of empty place here. It was really we did it most of the work ourselves. We had some alpinist with ropes to ensure the operations. And then we build up, and then we digged here inside. So if you see that, you might not be motivated to do such a work, but for me now it's done. I'm happy about it, but it was really hard work here. So I put out here one wall, and we organized the space a little bit different to have more light inside and a bigger stube. It's a kitchen place. So we put out one wall, and we underpinned it with a steel beam here. It's not here in place. We will see it here. Here you have the steel beam to carry the wall of the upper floors. You have 3 stories of big walls were to be carried if you take out a wall here. And then we digged out the ground, and we put some insulation gravel, 60 centimeters, a big layer of insulation. And then we started building up our building from the inside. We put another wall, a new wall. This wall is interesting. It's a timber wall. We call it cross-laminated timber, CLT. It's a massive timber, but it's a double wall. And you have an interspace of 20 centimeters in between. And here we have all our pipelines, all water, ventilation, electricity, and you can have a look inside later for inspection or if you have a leakage. And everything is here, and you don't have to drill in stone walls to put all your electricity cables or pipes inside. And so this wall, he was collecting all the water system from the kitchen, from all the kitchens, the bathrooms. They were all connected to this double wall. It was going through the building, and this might be a good advice for you if you restore an old building. Foresee a place where all your cables are grouped and you can have access later, because technology is changing. So after, especially for computers, you have to change all cables after 20 years, etc. Yeah, and then we built up a tiled stove. The old one was really not nice, so we built a new one, but always with historical elements we recovered somewhere. And here we heated the first time here just before winter time coming, and we had, you see, we have here a timber ceiling. There are stacked planks. We have just planks. I will show you. You can just take planks and nail them together. If it's a building where you have no crane and you have to carry your materials on your shoulders, it's easy to carry a plank, and then with planks you can make easily a timber floor. So this on the right on the top was the old building here. We're quite dark, but we recovered everything. We covered the old painting, we recovered all the wood, we completed it. We completed the nail. It was handmade iron nails from a valley, sometimes in Italy. And at the end, you see the inside is a modern stube with all this old wood. And this is for me the heart and the memory of the house. So I think this is nicer than a new house where you have white walls everywhere. Here you have all the memory of the house inside and the old living culture. The inside the walls, we doubled the wall, the stone wall, with a timber structure, and we filled it out with clay panels, earth panels. I had a carpenter who is passionate by the combination of clay and timber, which is a very good combination for nice indoor climate, for moisture. So the elements are prefabricated. They are 4 centimeters thick. You nail them on the 2x4 structure, and then you have a final layer to finish it up. You see the bathroom here with a clay wall, and we never have condensation in this bathroom because the clay is absorbing the moisture difference. Yeah, and then we have finished the first part. it was the hardest part, and the last part was a big work too, but it was not so dirty. So the barn house here was in so a bad condition, so we break down everything. It was dangerous. It was a barn house, so not done for living there, and it was bad structure and bad design. We just kept the bracing system. So we just kept 1 meter of the roof with the bracing system, and inside we broke out everything. We only had 4 days to do everything because rain was coming, winter was coming, and in 4 days you have the time to break out everything and to bring the new house inside. And this you can do with timber because everything is prefabricated, prepared. We have numbers, you have a logistic where everything is organized, element arrives just in time with a truck. And here you see there's just a difference of 3 days maybe here. Here you see the new house in house growing up. It's a 2x4 house with passive house elements, so highly insulated, airtight, everything we need, but with big openings. Today in our modern culture, we would like to have a lot of light. We want to have the connection to the outside, and we are not closed in caves as the old farmhouse had lived before. So, and then we have our tree. My tree is part of my design work, and now it's part of the design work of my son. My son Sylvain, you see him here. He was studying here already, and he did all the parametric design of the tree. So he did all the computer work, and he is now well earning money in Switzerland. He's in a very big company. He's specialized for parametric design and happy to be there. And this was his baby here. He assisted for the fabrication. We went to metal carpentry with 2 masters. They had so fun to build up. You have to dwell everything together, and it's not so easy to dwell because you have, with the heat, you have deformation. Everything must be very preciseful. And to put some wood parts inside, it's not a problem for a metal carpenter. So it was prefabricated. It was a big wheel of, I think, 4.5 meters. So it just went on a truck, and it was prefabricated, and it was, we can see it. I hope we can see it now. It's coming with the crane. You see, you have to put it in time because after the roof, it's too late. You have no place to put it. My son came a little bit late. He wanted to watch, but I took the pictures. So this was the 3rd day, and then we finished up here the inside work. So this is timber working here, and you will see we have. You see the central support point here, the tree. If you are in the lowest part, you have the biggest load, so you need a strong structure. And if you're going up and up, you're reducing your column. And here we use the innovation, innovation. We built the first floor with this point supported. We only have a column and no beams. We only have a plate and a column. So we developed in Innsbruck the so-called spider connector. And the spider connector, he gets the innovation prize of Germany of all disciplines, in Great Britain of all disciplines. And he changed the typology of houses now because we can build high-rise houses only with columns and plates and not beams anymore. So we save in every story, we save 30 centimeters. So after 10 stories, you have 1 supplementary story because the height of your system is reduced because there are not beams anymore. So it's a clever system. And the first one was here. The problem was when you design a nice structure, you reduce, as I told you, you reduce the material to have a filigree structure, and then you make a cost calculation by a carpenter. He will tell you that the structure is so complicated, so we had half of the quantity of the next floor, but it costed double the price. So the price per cubic meter was 4 times more than a massive structure. And normally you choose for the cheapest solution and you just give up. But we just decided to do it ourselves. If it's so expensive, we did it ourselves, and it was really not so complicated. A carpenter will tell you to put beams parallel. It's half of the works and puts them radial, which is not true. You have the same number of beams. They are all CNC cutted. They have numbers. You just put, and you see my sons, in one day, they put all these 350 beams. They're all different, but everything is CNC cutted, and it's really easy to do it. And then we had our structure for a good price. So, sometimes you are badly advised by the prices, and most of the buildings, it said if it's complicated, you get a high price, and then you have massive structures with easy solutions, which cost less but have more material as needed. And this is one of our problems today of building. We use too much material because we want to make everything very simple and very heavy. And here you see the finished these structures. You have the spider here. The spider is a local reinforcement for punching loads. It was the first one. You see here the column and the ceiling. And you see also we have quite open space with a lot of lights combined with the old structure. The sleeping rooms were in the old structures with big walls, and in the new structure we had big openings and lots of light. This is a cut in the house. You see, I told you we have this column. First we had four columns in the barn house. Now we have only one central column. So we reorganized the space completely differently. And you see on the top we don't have even a column because the loads are so reduced. So we had a truss beam here for the roof. And so you see the increasing number of elements when you're going down, when the loads are multiplying. And you see also I used half of the cellar height because my tree, he needs some space. He needs height. If not, your head is too close to the tree. So I had 3.30 meters, and then my son is over me. He wanted also 3.30 meters, so he went up. And my last son, he hit his head on the roof, and so we have to lift up the whole building for the central part. And everybody has now his 3.30 meters, but we need this space because it's a big space, and you need more than 3 meters here. The conclusion is here. We had some strategy to preserve. Especially myself. I don't have a heritage committee or some administration people asking me to preserve everything. It was myself. We get help after for preservation and we got some prizes in architecture too. But the idea is, and I think it could be general, if you have an old house, you have parts who are still in good conditions, who have a history, who have a value. You should preserve them, and we have worse parts in bad conditions. Don't hesitate to put them out, to break them down, and to combine them, to open it, and you see the final concept. You see, you can. We have one concept was to reduce our living surfaces. We don't need 250 square meters for a family today. We call it the principle of sufficiency. We can reduce our need of living space. We always wasting space and money and energy, so we can reduce it. And you don't get subsidiaries in Tyrol if you have a luxury apartment. The surface must be under 140 square meters, so we reduced them. So we just renovated. The closed space renovated was only 450 square meters. We had 600. And with the 200 square meters, we had an open space outside. So you don't have to heat it. You don't have to build it. You have a nice terrace where you can stay in summer or even in fall. You can eat outside. You can wash your windows from outside. You have a protected facade. You have transparency. You can look through. It looks still you find the old volume of the house, but you have a deepness and you have a transparency, which make it lighter and modern. So, and you save a lot of money if you if you build up only 450 instead of 600, you can calculate it saved money. So we reduced the surface, and then I didn't talk too much about energies. I'm sorry, but I think you know a little about it. A passive house, it needs very few energy. So we have the passive house standard in the new house, and we had the EnerFit standard. We had different energy standards because it was difficult because of the situation. We had the first floor in the old building. It was in contact with the foundations, and we had thermal losses and etc. But at the end, we are CO2 free. We have a heat pump. We have thermal. We have the geothermal energy. We have photovoltaic panels. So this is all the energy we need to heat the house with quite a good balance. And so the cost of the house to heat it are very low. We have less than 100 euro a month warm water and heating together. So it's really not so bad. And then we did a lot of things ourselves. And I really was happy that my children, they played the game. They learned how to build, how to handle machines, how to do carpentry, and the most important things, they are really proud of their work. If you offer everything and they just buy it, you don't realize what you have done as if you have worked yourself it out and you save a lot of money. And I know we are under 2,000 euro per square meter, which is for today. You do everything with companies. You don't have strategies. You are over 4,000. You have the double of the price. So if you're young and you have energy and ideas, you can afford a house by doing a big part of yourself. For me, it's easy because it's my profession, but I saw my children, they learned with it. So the other one get professional too. But it was really a nice exercise, and it shows that you can pay it and you can have the best standards. It was always a challenge to say, yeah, a high energy standard, it costs a lot of money, we cannot do it, we pay it later, etc. This is not true. If you can, if your concept is good, and if you make a balance over the first 10 years, all the saving for energy and the saving of many superfluous things for too big surfaces, big volumes, or cutting down things you can preserve, you can save so a lot of money that at the end you can win about 30-40% of the price of a house, and with the best quality. Yeah? This house has on every level the best quality. You can watch all the details. It's really a high quality house. So here you see the house from the top, and you see here over the car you see a building I will speak you about, because we are here in a valley with a lot of snow sometimes. So overnight it can happen that we have 50 centimeters of snow. So I wanted to build a carport. And this carport, I built it just last summer. And here we're coming back to nature. If you see the structure here, we don't have parallel beams. We don't have one sense for the loads. Everything is connected, interconnected. And it makes sense if you have a square ground plan to carry loads in two directions and to interconnect all the sections. If you have simple beams, the weakest beam, he can break, he will fall down, and the neighbor even don't realize it. He cannot help, he's not connected to it. If you have an interconnected system, you have the strongest pieces will help the weakest one, and then then the final failure will be a medium value of all the strengths. So especially in wood, you have a big variation of strengths because it's a natural material. If you have we call it a redundant system, this system can help himself. Redundant means it can mobilize additional capacity of load carrying, and the load capacity it's at least 30% higher as if you have the same material and you have only simple beams. So I think a good engineer should know it to work on multi-directional systems, on spatial system, than to be happy with simple beams, which are easy. They are easy to calculate. They are easy to earn money, but the system is not very clever. And I think this was important to do it. So in the code you have some possibilities to take account of it. So you can you have a system factor, and at the end, I grew up with we call it mega structures. I built my first building was 10,000 square meters, and you have 20,000 people under the roof. And I never will build a simple beam if I have 20,000 people. If one beam is falling down, you have dead people. If you have a redundant system, you hear cracks. You're advertised by noise, by transformation, and the people have a big chance to get out of the building before the system is collapsing. So it was one of my basics on big buildings, and I did a lot of big buildings with thousands of people on the roofs. I never will build a simple beam on this kind of building. And I don't have it here. I did in Paris a indoor athletic hall, which has the same size as the swimming halls they built for the Olympics, but there was just simple beams, and I don't understand this way of thinking. So the grid. So the question is how to have continuous beam in two directions. You can pile them up, but you're losing height, which is not good. So the idea is to have different layers. Here on the picture, on the top on the right, you see here the red, the green pictogram. We have here 4 layers, and every second layer is continuous. So you have continuity. You just have to take care about the first and the third layer to connect them together to work as a simple section, and the second and the fourth layer. If you connect them, you need a shear force connector. The shear force is always connecting the longitudinal stresses to the beam. It's kind of an internal lift to bring up the forces. If you have a good connection, you have at the end, you can have 3 layers, and they have the same stiffness and the simple layer with the same section. So this was a little bit the target. The first grids we built, it was 30 years ago. Here, this was a hotel I did in Les Arcs in the sea station. The steel connectors were pins, metal pins. We drilled them and we hammered on it to have a shear connector, but they were too elastic, so I had a loss of about 30% of the section. So the system was not as perfect as I hoped to be, but we did some structures here. You see, we have nice structures. 30 years ago already, the technique we know, but now we want to improve our shear connector. And we have a new shear connector. You see it here on the bottom. It's a sharp connector. He has micro teeth. He's coming from the airplane industry for brakes, and he has 6 times the stiffness of our classical connectors, 6 times more stiff. So we approach the stiffness of a glued section. With the big advantage, we don't need glue. And if we, at the end of a life of a building, we want to dismantle it, we just put it out and we can use the pieces again. With glued timber, you cannot do that. When it's glued, it's stick together and you cannot separate it. So this is another big advantage. And then I build a model here very quickly. You can put, the problem today, especially in the south. The car are all overheating on parking places, so you have shadow. Then you can have vegetables on. You can grass roof for absorbing water. You can have photovoltaic panels. So there are so many uses to combine this with a shelter. And then we build it. I build it with timber columns. Timber columns. The problem is they were in the ground in contact with water. But we have one local species, it's Robinia wood. It's a hardwood. It has the same characteristic resistance as tropical wood. And we just dig we dig the hole here, and we put the poles inside, and then we call it a filter beton, which keeps not the water back. So the water is drained. So the column will be always dry. And this kind of wood, you can have it in 200 years. It will not rot away. And then the target of my project was not to use glulam. I don't know if you followed the wood prices during the pandemic. The wood prices were multiplied by 3. You have a cost rising of 300% because glulam products were sold in China, in the States, with higher prices. So all the carpenters here had to pay the same price, and some get difficulties to survive because of the high prices, because they had already contracts with customers. So I promised to the carpenter we will find a system without glue, so you can buy it here in a local sawmill with massive wood. And I was consulting here in Tyrol to get what I'm doing to get my massive wood, but I didn't find it. It was only glulam or the Gaffer. It's also a glued. So I went in my home country to Bavaria, and I found close to the border a man who had a mill here. He has a Gattersäge. It's a mill, a frame mill. He is producing 20,000 cubic meters, and he's cutting long beams, 15 meters long, no glue, and the quality is excellent. He's drying it, and here we see this is all the wood we needed for my carport here. Then it goes in a drying chamber to heat it up to bring it down to the right moisture. And then we had here high quality wood without glue. It was cheaper. A glulam cost about 400, 500, and this wood could about 300. So you get better wood. You have no glue. You have stable prices. You don't depend on global market prices. So this was the idea of our project. So we built it up here, the columns. It was done in 4 days. At the beginning they had a crane of the transport truck, but then we did everything without crane. So we fixed up here the columns, but we did not cast the concrete. We put it in when the geometric frame of the carpet was connecting the top to have the precise position of our top of columns, and then we could block the concrete. Here, this is a filter concrete. And then I put a seal concrete on the top that the water from the road surface could not penetrate here. Yeah, and then we did layer for layer. So they had really a lot of fun. In 3 days, they put the layer with the new conductors, and after 3 days, it was done. It looks a little bit Japanese. It's coming. It's old technique. We know it from the pagode ones, but now we have more knowledge about redundancy and higher security and connectors. And this was just 1 month before I left for Bhutan. And here you see the roof, the seal roof on it. And then I went to Bhutan, and I had a 3-month course where they learned designing, calculation, making a project, drawing the project, making a model. Here the model. I met the vice chancellor of Bhutan, who who agreed. I asked him it would be nice to have to make a prototype structure with my students. He said, go ahead, I finance all the wood, everything you want. So we built here a model. This was an AutoCAD model. This was our handmade model. And then my students had to work in the workshop. They never have seen wood before. They know how to cast concrete or how to cut a piece of metal, but no wood. They have never seen a wood. The only thing I insisted to invest, you see, is a chopsy, a Kappsäge, to have proper cuts, because they only had old rusty tools and you cannot work with it. They have no culture about maintenance of tools and no drillers, no nothing, so no screws. And so we did our best. And here we have steel columns, and then we were going ahead. So we were 15 people. We had 2 teams, one in the morning, one in the evening. You see, they are happy. Yeah, and then the last days we worked early till the night because we had only 1 day left to finish up here, the last layers, and then the last days they get their certificate. And 1 hour after we did our inauguration, here's a model, here the finished cardboard. So it's to drink tea, and then we had a cake. And yeah, that was it. This is my working dress in Bhutan. It's a go. But I was happy to finish up in time. It was a real challenge for everybody, but it was a nice experience. So we are coming to the end. I hope you get some nice ideas for your next house. And I hope, Rainer, there were some interesting aspects about energy efficiency, saving energy, also on gray energy. I think it's important. You know, Bhutan will build the biggest city in timber now. It's a city over 1,000 square kilometers. It's the same size as Vienna, built all in wood. But the concept, there are over-designed, huge, heavy elements. Nobody knows how to fabricate them in Bhutan. So they're already thinking to build it in steel and to hide it behind some wood clothing. But I will continue to work to convince to come to systems who are compatible with the technology and the materials they have in Bhutan. Thank you very much. Thank you to all the outdoor auditors. I hope you could follow a little bit.
Yeah, thank you very much for this interesting presentation. Thank you. Yeah, now we have some time for Q&A, for discussion. We can have a look if some questions in the audience and the online. So if you have some questions from online, just type in the chat and we can answer the questions. And if you have some questions in the audience, I'll come over with the microphone that the colleagues online could hear you also. Yeah. Are there any questions to Michael Flach?
You're too much impressed, eh? So you can come see me, yeah? It's only 1 hour with bike.
In Schnitztal.
Go to the Schnitztal. I have many visitors already.
It's nice in summer and wintertime. So in wintertime you can go skiing.
Sure.
And nice for hiking. Yeah, some icebreaker question maybe.
Have you some question from outside?
Yeah, we can have a look. Yeah. Amazing lecture. I wish to live in a house like this. Do you know about any other farmhouse that are going through such a transformation in Tyrol? It's an anderes Gebäude, das auch so.
I think this one is quite unique, but I know there are many young people say doing some restoration work. We have sometimes on TV, you see on Tyrol television, you see some examples. but every project is a own challenge. So you never can use the same solutions on every project, which make it sometimes difficult, but it makes it also exciting because you have your own challenge and you have to respond to the parameter of your project. And refurbishing is much more complicated than building a new house. You have a green ground and then you put your ideas inside. If you have an old house, the old house has so many surprises for you of good or bad conditions. You have to adapt. But this makes it really interesting. Also for me, it was a good challenge and much more exciting than to build a new house.
Yeah, but he asked if there a similar technique is used, not for a farmhouse, but for a from the 70s, I think. There is one building in Innsbruck, in Kohlweg, in a similar technique like you did, but not with horizontal panels, but with vertical. So it's a 3-story building, and they used vertical panels. I think a little bigger size. So you choose 6-meter length.
6 per 3 meters, yes.
But
it depends on every project. We did some literature research and we found many examples with different solutions. And there are already many examples for insulation or thermal refurbishment from outside. The principle is you should make a digital inventory, prefabricate, and then work with prefabricated elements in a very short time. This really works, and the precision of the digital technology is so good you cannot make errors. In 30 years, we never had errors of geometry because CAD is
so precise.
It's precise, and you check it, and so thanks to the digital technology, we have a big help. And the only problem is with the old house, you have to make an inventory. So you need a laser or tachymeter to make a state of art of your building, and then you can go ahead with prefabrication. But wood is a nice material because you can prefabricate. It's not heavy. We have more and more problems today in cities to build because some cities, they don't allow any more big trucks in cities doing construction. So in timber, the advantage is you prefabricate, you do 90% of the work in a workshop outside, and then you bring everything to the building site in 1 week, 2 weeks. Everything is finished. Now you have seen the 2 days for the refurbishment of the facades, 4 days to make a house in house. So especially for the areas of the weather, we have to be very fast sometimes. You cannot, you should not do it if you have heavy rain. You have all the water inside your building. But you have, we call it a dry building process. If you cast in concrete, you put a lot of water inside the building and you have to wait. It's drying out, so you're going much faster in timber, and it's lighter, it's ecological, you have less transport. So everything is positive for to make it in timber today.
There's another question, very inspiring talk. Thank you for this talk. And he asks, I assume I want to apply some of these ideas on my own building. Do I have to design and install everything myself? Are there any providers for the design work and carpenters who specialized in the execution?
I think we have a lot of good engineers and carpenters. Here especially, I need sometimes the advices of the carpenter for rising. They really know how to handle. And many carpenters have their own design office sometimes. It depends. I'm really special. You have seen my structures are in 3 dimensions. There are organics. There are, because I like it. most of the engineers prefer simple things, but they have the knowledge to advise you. I think the problem is we have a profession with a big number of risks of high responsibility. So if something is going wrong, we need insurance, we need declaration. We cannot work just to give advices without any administrative structure. So you need a design office, you need an office with an insurance company. So you have to contact these people. So there are, since I am teaching here, we have a lot of additional engineers here who know how to build. So in the last 20 years, many things happens. The best country is really Switzerland. Switzerland, they started 40 years ago with the Holzfachschule in Biel. And every year they educated 10, 15 people, and they covering Switzerland. Every village has a engineering office. My son is working in an office. They were last year 12 people. Now they are over 100, and they're still looking for people. So there's a lack of personnel.
So education is key.
But things are going ahead because also the engineers, they realize that timber is a material of the future. There is work in the future. And even with economic crisis in timber engineering, there's still enough work because the market is growing, the part of the market.
Especially in refurbishing, the market is there. And
the market is there, and the market share between concrete and timber is changing. So the part of wood is increasing.
And also not only for buildings, housing, and refurbishing, but also what you showed us in the last slides with the carport. This could also be used for as a structure for PV elements. So nowadays, all the PV substructures are made of steel, galvanized steel, and this is a chance to do it in wood and long-lasting and in an ecological way.
With a positive CO2 balance.
It's a positive, yeah. But there are no examples for that already for some PV structure? Or?
My carport will get a PV structure, so
okay.
It's the first one. Yeah. But yeah, the market is growing, but I think now the supermarkets are thinking about covering the parking places. Mm-hmm. Because first problem is overheating in cars. You cannot leave a dog inside a car now, or your handy and electronic devices in a car is overheating. So we have the overheating problem, and then we have now problems to protect our cars from heavy snow, from gravel, from natural climate problems, and we need to face this for the PV. It's a nice place, and we have to substitute also the asphalt. The water draining system. So we need some additional devices now to compensate our road covering.
Yeah, the PV could be for parking places, but also for agro PV.
Sure.
That's also development.
We have a lot of small markets now, then especially in France, but I think here too you have the weekend market, and it's nice to have a shelter, and you can, you have polyvalent shelters for markets, for musicals, for dancing, for marriages, you have so many public events where every village can have a small marketplace, and there are already, you see all these music pavilions, but I think in the future they want to cover people also to protect them from rain and from sun. The sun is a big problem.
Right. Yeah. Any other questions? Let's have a look again on the online.
can also speak German if the
Yeah, if you would.
language barrier is too high.
German is no problem. There's no further questions, so yeah. Then we come to an end. I would say thank you very, very much.
Paying attention to come here.
Yeah, thank you to the audience. Thank you for the online participants. That was.
Hope I could give some ideas. This is the most important things.
Really,
all my students, they want now build a tree house with a tree column in the middle. They get inspirations, and I think some of them will do that.
Yeah. Yeah, so this was the last lecture of this summer semester. So yeah, good luck for your task, and yeah, looking forward to what you're hand in, and especially for your own research questions in your field of study. That's also interesting for me to get some insight what you are doing. And yeah, maybe we will see again in the winter semester also. It will be given as a micro-credential together with a second lecture. You can study it as a micro-credential. That's the first Aurora micro-credential we created. So feel free to join. Thank you. Thank you for coming.